So very good morning to everyone here. So welcome to the 45th episode of Gyaniki Tech Talk. And today with us we have Mr. Chandrashekhar Chincholkar. He has over 29 years of experience in corporate finance, capital markets, and manufacturing and consulting. He's done significant fundraising for corporates in the last many years, both on debt, equity, and structured funding areas. He has done domestic and international roadshows for more than 150 companies for portfolio investments as well as fundraising through IPOs, QIPs, and secondary placements. He has been involved in significant policy level workings and has been involved with policy level research in the areas of renewable energy, CSR, electrical mobility, agriculture, and so on. So it's a pleasure to have you with us today, sir. Over to you with your presentation.
Can you see the screen?
Yes, sir.
Yeah.
Yeah.
So good morning, everyone. Myself, Chandrashekhar Chincholkar, Strategic Advisor, Electric Mobility and Clean Technologies at KPIT. So brief background about KPIT. KPIT is a $350 million mobility software firm globally with offices at 20 locations worldwide. Significant presence in Europe and US and Japan and China. We have 2 offices in India, and we do a lot of work, major work on the software side. So we started doing research on R&D for electric mobility around 5-6 years before. And after that, we not only developed the powertrain, we also developed the first ground of fuel cell in the country. So let us try and understand this particular topic of energy transition, electric mobility. And I also added the hydrogen economy part of it. So the index for today is, what is energy transition, what is electric mobility, components in electric mobility and clean technology mobility solutions and hydrogen economy. So I have been given around 25 to 30 minutes to talk about this. So we'll try and quickly run through all the parameters. See, the world is currently going through significant energy transition. And what I should say is that this transition is not a choice. This transition is actually a compulsion, because if we do not survive the environmental issues and problems, then the world will get into serious disastrous trap. And that is something which is very difficult to reverse actually. So if you look at the entire energy transition area, we know the entire world has committed to the Paris Agreement in 2015. Basic aim is to reduce temperatures, maintain temperatures not going beyond 1.5 to 2 degrees from the industrial levels agreed upon in 2005. Obviously, the focus is on CO2 emission reductions. India is obviously one of the third largest emitters in the world. And you look at globally, 2 largest emitters other than India, China and USA. China, obviously, with large industrial base, contributes 30% of global emissions, and US around 12%. So India has also committed in COP26 about phasing out of coal and reducing power generation from coal by 50%. By 2030, and obviously complete phasing out by 2040 to 2065. So India's commitment to net zero is around 2070. So looking at that, these commitments are fair, because as a major country which has large coal reserves, it is very difficult for India to 100% shift to renewable energy at the earliest. But obviously the government is very, very serious and committed. So next target is basically what government committed at the COP26, Prime Minister Modi, is 500 gigawatt of renewable power by 2030. So that is the next big commitment. And see 1 billion ton CO2 emission reduction by 2030. Obviously, current forest cover is around 21-22%. Some of the government records show it at, I think, little lesser or little higher, but the ultimate target is to move to 33% forest cover in the next 10 to 12 years. So plantation and agriculture related activities, obviously afforestation, then government funding for various plantation schemes through Campa. Campa was a fund which actually the money was locked in for many, many years, and the central government actually distributed 47,000 crores to various states in August 2019. So that money, I believe, should have been effectively used. So moving on from there, Why this energy transition? Because India currently imports around 85% of the crude requirements, and our import bill is significantly higher. You can imagine if crude prices have gone up by around from 75, 80 or $90 or $100 to $120, what this can actually mean for India. So obviously, we are lucky enough that the current reserve forex reserves are almost like 600 650 billion dollars. So India is able to absorb the shock in terms of foreign currency. Otherwise, the rupees already has started depreciating, but obviously it will benefit our exports. At the same time, the imports will also get impacted. So the government is definitely in a position to cushion everything with so much of forex reserves. India currently is $3 trillion economy, trying to move to $5 trillion. And one very important and major factor we should understand is that the elasticity of power or energy requirement to GDP growth is roughly in the range of 1.4 to 1.5 times. So if you are planning to grow at around 8-9%, in the next 4 or 5 years, which most of the research houses, World Bank and IMF and everybody has predicted, then obviously the demand for energy will compound at around 12 to 13% on a per annum basis, which is significant increase on a year basis. And that is one area which will actually lead to more energy demand in the future. At the same time, the China plus one India strategy is something that will definitely benefit India in terms of energy demand. So we have seen what has actually happened in this October, November coal shortages, September, October coal shortages, and we've seen what are the power rates, and the power rates actually went up to as high as 22 rupees per unit. So it is something which is very difficult to manage at times, and more important is that the delta or the increase in power rates as compared to the shortages is significantly higher, and that actually puts a lot of pressure on the manufacturing sector, the production related areas, the use of electricity by hotels, commercial complexes, in-house use also, house use also. So these are all areas which are going to be very, very challenging in the coming days. So that's why energy transition is very, very important for people to understand. Our current capacity is 100 gigawatt. We'll probably go to 500 gigawatt in the next 10 years. Uh, and most of the major power generation has to actually come from solar and wind, because uh, you know, currently there are coal plants have to, obviously the numbers have to actually go down. Solar, because there is reasonable amount of growth opportunity. Wind, there are limitations because wind energy, the location is very important. Otherwise, the PLF doesn't actually benefit you. The wind PLF today is in the range of 16 to 17%. Solar PLF is in the range of 22 to 25%. And unless you have proper wind location, it is very, very difficult to get that kind of an efficiency. And most of the wind power generation is basically in the months of July to June to September, October, because that's time the entire season is very windy, and that actually leads to incremental generation of power. So new power models have to come up. People are talking about uh, coastline related power generation through using wind turbines. So that is also an opportunity for people who are there on the coastline of India. If you look at the per capita energy consumption in India, it is around 1,200 units currently. The world over, some of the major developed nations have as high as 4,000, 5,000 units. Even if you take around 3,000 units, you can imagine the kind of power requirement that actually is required in the coming days. So government is also pushing large amount of LNG. There's almost 16,000 kilometers of pipeline in the country today for LNG. And so LNG can also get converted to hydrogen, but obviously it will not be a green hydrogen. It will be a blue hydrogen. So CNG is also being used by people, but there are challenges in terms of CNG stations and etc. The pickup in terms of CNG vessels has happened to certain extent, but it's not to the extent that probably the pickup in electric vehicles has started happening. One very important parameter that all of us have to really worry about or uh, note is that decarbonization is something that needs to be done both for mobility as well as for manufacturing. And roughly around 22% is what is there in mobility related areas. Manufacturing is much larger, but one must understand that manufacturing related decarbonization is not easy. It's going to be very challenging. It's very capex driven. And in comparison to that, mobility related decarbonization is something which can be seen very fast, say like something like 100 200 electric buses or 100 200 fuel cell electric buses. running on the road, and you can actually measure the kind of pollution reduction that can actually happen because of these buses. So these are all areas which are very, very important for India. And other than this, you can imagine, currently we consume 40 million tons of diesel for buses and trucks. So overall diesel consumption is 80-85. So you can imagine if the economy becomes 5 or 7 or $10 trillion, what will be the diesel requirement? And we will unnecessarily keep importing ourselves and keep spending our foreign currency. It doesn't really make sense for India to depend too much on the energy or the crude imports from all over the world. So at the at $10 trillion sort of economy size, I think the diesel requirement could go to as high as 200 million tons, which is very, very difficult for people for the country overall, because the forex requirements that will be significantly higher. Power consumption currently is around 400 gigawatts, which I believe should be in the range of 850 to 900. But if you take the elasticity factor as well as the one China plus one demand, I think the real number could be as 1100 or 1200 gigawatt. So, the power requirement is going to go up suddenly, and we are at a stage where, so much of power consumption is happening on a daily basis at homes, at factories, and the GDP economy increasing. All these parameters are like really going to put the energy demand in a much faster pace from the current levels. So addressing climate change, farmers' income, all these areas need to be addressed. So definitely, that these are all areas in terms of energy transition one needs to really look at. Biomass-based renewable generation is one other opportunity for India, because India has large biomass which is actually wasted in some parts of India, and in some parts it is used as a cattle feed or something like that. But obviously, it should be put to much better use, including the municipal solid waste, which can actually work around and help you create something which can be green. So we as a company have worked upon two technologies, and those two technologies are, one is microbial route, other is a gasification route, and those two technologies can actually take India to the next level in terms of generation of green hydrogen. The last line is something which is very important for the world to understand, because energy transition, McKinsey came out with a report and said that this entire decarbonization effort will actually require $9 trillion every year, and for the next 30 years. So the money required is huge. World actually doesn't have that kind of a free cash flow to really invest, because this is something which will require large amount of free cash flow, and it needs to have a different financial model than a regular 20-80 or 25-75 debt equity ratio. So I actually quoted on LinkedIn few days before, and the response has been very good in terms of people have responded to that particular thought process and idea. And a differentiated funding model actually needs to come into place. So moving on from here, what is electric mobility? So electric mobility, as all of us are aware, a sustainable and healthier clean route for cleaner noise-free transportation. And it is basically a principle of using electric propulsion for a wide range of transportation types. So whether you talk about two-wheelers, three-wheelers, cars, buses, trucks, off-road vehicles, all basically are in the right mode to actually go towards electric mobility. India has, I believe, more than 10,000 vehicles as of now on the roads from an battery electric point of view. Obviously, hydrogen fuel cell is something that is just taking off. So, uh, the uh, major important thing is that if you look at something like buses, the requirement currently is the current bus population is around 20 lakh buses, and the demand for buses in the coming years will significantly go up. So one needs to really look at these kind of solutions, but obviously there are challenges in terms of battery solutions. These battery solutions, lithium ion is something which is very, very scarce raw material, and it is very costly also. The lithium prices have gone up by 40-45% in the last roughly 6 months. So, cost-effective solution is very important, because if you look at a bus cost, almost 40-45% of the bus cost is actually coming from only the battery part. So if the lithium prices keep going well, obviously it will not be viable at any point of time. So hydrogen fuel cell is definitely a good solution, because companies like OMIUM, then Reliance have actually committed to $1 per kg of hydrogen in the coming days, and the efficiency of hydrogen is very good. 1 kg of hydrogen can actually give you a mileage of around 14 to 15 kilometers per kg. So if you look at what is our focus has been on buses. So in terms of what is the electric powertrain which actually drives the vehicle, So these are all major components of electric powertrain. If you talk about a battery electric powertrain, then you will have a motor controller, transmission, battery management system, electronic control unit, and then you will have a battery. If you talk about a fuel cell vehicle, it will have fuel cell plus all these components along with a smaller battery for any peak or trough requirements. So, as a company, we have developed one of the most efficient powertrains in the country, and our power efficiency is significantly higher. This 0.65 kilowatt hour per kilometer, without considering the GVW, the current rate with considering the uh, GVW, that is weight of the bus, it should be in the range of 0.85. So that is something which is very, very good. It is 20% better than the current efficiencies in the market and in terms of the competition. So, and then that is something that will actually benefit India in terms of Make in India initiative. So few of our buses are actually running in Calcutta, and I'll show you the performance of these buses. So the integrated powertrain and battery electric fuel cell vehicles is the right solution. So if you look at intra-city operations, the best is to go for anything less than 250 kilometers. It is important that you should look at battery solution. If anything is more than 350, 400 kilometers on a daily basis, you should obviously look at a fuel cell solution. Obviously, the hydrogen currently the costs are very high. They are in the range of $5 to $6 per kg. But obviously, all these bigger companies are committed to bringing the
Sorry to
hydrogen costs
interrupt
down,
you,
and I think that will
Chandrasekhar.
happen in India because India has uh, India
Hello.
has very little choices in terms of really moving ahead with energy transition. So the performance of our buses is significantly better. You can look at the availability of the buses is around 98, 99%. And we've done more than 5 lakh kilometers on these buses. Average uptime has been 98%, and we got a customer satisfaction score of 5 over 5 for the last 4 years. Actually, it is last 4 years, and we have more than 2 lakh happy passengers uh, in this particular location at Calcutta. So if you look at the fuel cell, targeted basically for long range, high affordability sort of a model, development of indigenous fuel stack in the first time in the country has been done by KPIT. A very cost effective solutions. Our current costs are actually matching with the global peers who are in business for the last 15 odd years. So if we are able to move ahead with the volumes, I think our costs will definitely come down by 50 to 60%. And the target given below is $400 per kilowatt. That is the target we are looking at. And we are very sure if we are able to go beyond 1,000 buses, we should be able to bring the cost down to that this particular level. So it's a very, very highly efficient, machine. Your internal combustion engine, despite being in business for last 50 years plus, the efficiency of the engine is not more than 25%. But a fuel cell at the nascent stage, the efficiency is already crossed 50% level. So we are looking at improving the efficiency from 50 to around 60 or 65%. So these are all areas of improvement which our technical team is working upon. So using hydrogen as a fuel, just to take you through, because that is very important part of the entire sector of area of energy transition. Uh, so what are the scenarios? Hydrogen as a fuel, you look at the specific energy is almost 3 times that of diesel. Carbon neutral, then the efficiency is very high, currently 50% as compared to diesel engine, and zero emission and zero pollution, fuel. So what are the pathways to generate hydrogen? There are five pathways to generate hydrogen. Currently, natural gas, SMR is something that is basically used currently in refineries. They import LNG. After importing LNG, they convert that LNG into hydrogen because refineries require large amount of hydrogen for their cracking purposes. And the current requirement for hydrogen for refineries is significantly higher. So refineries and fertilizer companies are two major users of hydrogen currently in the country. And India currently has around 6 or 6.5 million metric tons of hydrogen consumption, which is roughly 8% of the world hydrogen consumption. So it is not difficult for us to move really to hydrogen. It can actually become much easier. Obviously, to move 100% to green hydrogen is going to take time, but obviously to start with hydrogen is relatively easier for India. So second opportunity is in terms of hydrogen generation is methanol reformation, and methanol reformation is where you use a reformation to from generate methanol from coal, and that is also another big opportunity where Niti Aayog has been pushing for methanol reformation, but obviously the one needs to look at the carbon emission. So to begin with, methanol reformation can be a good opportunity to have hydrogen being available, and there are reformers available which can actually be installed on a bus or a truck. and you can have an online, real-time generation of hydrogen from methanol for the purposes of transportation. So the third opportunity is water electrolysis, which most of us have heard about. You split actually had the water into hydrogen and oxygen, and that particular hydrogen is then captured basically for and cleaned up to 99.999% level to basically be used for transportation purposes. The last two are the hydrogen from biomass. These two technologies is one is a microbial route and second is the gasification route. These two technologies where KPIT has actually worked upon, and we are very confident that with these routes and with a little bit control over biomass pricing, we should be able to generate hydrogen in the range of $3 per kg. So these are all the pathways which actually can help everybody in terms of hydrogen generation, and this can make the transition much easier and smoother for the country. Now, battery is a very important part of entire electric mobility. So most of the batteries currently use are basically lead acid batteries, but the demand for batteries is very high. In government has recently come out with the advanced cell chemistry production link incentive scheme, which has been already been awarded. So around 10 or 12 large players have been awarded this particular PLI scheme, and the production under that particular scheme is going to be around 50 gigawatt hour. So it is significantly large opportunity which people are getting into, because I think India has more than 100 gigawatt hours of requirement for batteries every year. So that is a big opportunity. So battery, as I said earlier also, anything between 200 to 220 or 250 kilometer range is where battery actually works very well. And only unfortunate part with batteries is that it has large amount of the battery. Most of the batteries are actually lithium ion batteries. So currently we need to have alternative solutions, because lithium and cobalt are very scarce raw material. And these raw materials are actually having very high commodity prices, which are actually not sustainable in the longer run. But as the number of electric vehicles increase and the commodity challenges actually come forward, it may be very difficult to maintain the raw material pricing, which can actually have a direct impact on the use of these batteries, because people are moving to electric mobility basically to save on the running cost. Obviously, the initial capex cost is going to be higher, but if the commodity prices go up significantly higher, it may not really make sense to have too much of dependence on lithium-ion batteries. So, as a company, we have been working on the sodium-ion battery solution, and our currently few demonstrations have already happened, and larger, cell level demonstration will probably happen in the next 2 months. So that is an area which can be of significantly larger interest for the country. Recently, Reliance also took over a company in UK called Faradion, and Faradion basically has a sodium-ion battery technology. So, and the largest battery company in the world, CATL China, 2 months before they announced entry into sodium-ion battery. So sodium ion seems to be a stable, salt and chemistry, and the availability of sodium is almost 300 times more than lithium in the world. So sodium should be definitely a good solution in the coming days. So one should look at what is the global scenario for hydrogen. So the entire world is moving towards hydrogen. So you can look at the number of countries which have actually adopted hydrogen missions. India last year announced, Prime Minister Modi announced at the August 15 function about hydrogen mission, and the hydrogen mission has already been funded by around 2,500 crores to look at various projects which can be supported initially for a green hydrogen movement. So you can, the world over, you can look at the countries that are actually engaged. These are all countries who are all directly engaged and doing some projects on hydrogen. But then in terms of automotive industry, also everybody has started moving on to hydrogen as an area of interest, and a lot of people have collaborating, joining hands. Competitors are also joining hands to really come out with something which they can use as a technology which can be relatively cheaper as compared to the current prices. So in terms of the availability of money, if you look at the amount of money that is available for responsible investment, that is what we call it as ESG, environmental, social, and governance in related investments globally, it's around $31 trillion. Almost 450 funds have signed up for the Paris Agreement, and I think the number of funds will definitely increase from here only. And some of the top names like BlackRock and Amundi, CalPERS, These are all the people who drive the private equity and the capital market related investments all over the world. So if they are pushing for conversion to renewable energy or to energy transition, I think that is a very good thing, and this will definitely happen in the coming years. So why it is important for India? Because our import bill is ever increasing. We are consuming large amount of diesel every year. We are third largest polluter. 10 out of the world's 20 most polluted cities are in India, and transportation contributes more than 30% of urban population, urban pollution. One must understand the other statistics. One that is important to really understand is that Niti Aayog has come out with a report which says that in the next 1 decade, around 60% of India's population will be staying in cities. So you can look at the amount of urban mobility that will happen. And if we don't move by that time to batteries or to fuel cell vehicles, you can imagine the kind of pollution the cities will have. Other than this, the farmer, most of the agriculture, farmers have income which is very, very small, 17 to 18,000 rupees per acre. And most of the farmers actually own less than 5 acres. And they are all dependent on agriculture. I think if I remember correctly, the exact number is something like 57 or 58% of the population actually is dependent on uh, agriculture income. So these are all challenges which needs to be addressed. So hydrogen economy, look at what numbers it can actually throw. And I'm taking a very conservative price of 250 to 300 rupees per kg, which is around $3.5. So if that is considered, then you have biomass generators, you have electrolyzers, you have retailers, you have users, you have the machinery manufacturers, you have the dispensing stations, and all that economy put together. As we worked out, only from the point of view of diesel consumption related stuff, it can actually become a 10 to 12 lakh crore economy. If you look at, if we are very serious about mobility related or manufacturing related decarbonization, you can imagine the size of the industry. I think India has a potential to really clock something like 50 lakh crores, or sort of an economy size, if you are able to completely decarbonize ourselves. And obviously, as the economy size keeps growing, these numbers will actually keep growing. So, use of hydrogen for decarbonization of sectors like steel and cement is something which is very, very challenging. And that is an area which is, I think most of the cement companies are basically, tuned to this particular thought process of decarbonization. Obviously, it's going to be very, very challenging for them to do it. So government actually announced the hydrogen policy on 17th of February. So, what they're trying to do is to ensure that large number of people, large number of corporates actually get into this. And in the policy, what briefly they announce is waiver of interstate transmission charges for 25 years, giving access in 15 days, and trying to create the manufacturing zones, green H2 zones and ammonia zones, so that we are able to move faster. They're also trying to create a good mechanism for renewable purchase obligation related compliance. At the same time, what also they are trying to do is that they're trying to create a market mechanism for these kind of product lines, so that not only the corporates, at the same time farmers can actually benefit in the coming years. This was a car. We did a project with CSIR under the NMITLI program. And in October 2020, we demonstrated a existing company vehicle, which was retrofitted with a fuel cell. And we demonstrated this vehicle in October 2020. Then they went ahead and created the first fuel cell bus in the country. Unfortunately, the entire project got delayed by 6 months because of second wave of Corona. So post that, we did the launch on 15th of December 2021, and now the bus is actually under trials. So this is, our in between is our chairman, Mr. Pandit. On his left is Dr. Mashelkar, who's a ex-director general of CSIR, and also one of the Prime Minister advisors on Swachh Bharat mission. Then on Mr. Pandit's right is Dr. Ashish Lele. Dr. Lele is basically the current director of CSIR in Pune. So what is the potential impact of this particular related area on the entire economy? Uh, we can have reduction in fossil fuel imports by 40%, creation of large number of jobs, then meet a large amount of COP commitments of Government of India, and create a significant economy that's almost 6%. It can contribute to India's GDP. So in terms of, today everybody's talking about how you can actually meet the Sustainable Development Goals of the United Nations. So we tried to map the entire stuff and see how a hydrogen economy can actually benefit in terms of direct impact on sustainable development goals. So you can see uh, uh, the green ones, which are actually creating a direct impact: good health and well-being, affordable and clean energy, decent work, and economic growth. So these are all 7, 8 goals which can actually benefit the country and help meet the sustainable development goals. And now countries are also getting rated in terms of their contribution to SDGs. So I think it is very, very important for India to keep adopting hydrogen economy at the earliest, so that you are able to move towards this particular area. So, briefly about us, a company 100% automotive technology, 6,800 technologies, innovation awards, global patents, large amount of spend on R&D. So these are the areas of our work. So our offices, our clientele. So I would like to stop here so that we can take up any discussion or any questions.
Thank you for the presentation. So one of the first questions that comes to mind is, of course, laid out the benefits of achieving a certain, dollar per kg when it comes to hydrogen. Um,
Mhm.
but from a drawbacks perspective, right? Like first of all, when we say ICE and its efficiency, it's actually around more like 40%. Compared to when we talk about hydrogen, right from the like if you do a wheel to well analysis, right, there are certain challenges, which is why firms like Reliance are looking into green production of green hydrogen. So, can you highlight some of the areas, firstly, on that front, on the wheel to well analysis and the challenges that are, prevalent? And secondly, from a supply chain perspective, right? Today, with EVs, with rather, as I would say, battery electric vehicles, we see that the challenges are raw materials to do with the battery pack mainly.
Yeah.
Similarly, on the fuel cell front. So, in these two areas, what do you see as either roadblocks or drawbacks? However you wish to take that up.
See, in terms of generation of hydrogen, let us take first the technology part, that is the fuel cell. If you look at some of the larger companies globally, somebody like Ballard, which is one of the largest fuel cell companies globally, their current costs are in the range of $1,000 to $1,200 per kilowatt. So if somebody is wanting to use a 100 kilowatt, sort of a fuel stack, he will obviously end up spending large amount of money in that particular, investment. But obviously, with advancement of technology, with our effort in terms of ground of technology, we are currently are in the range of $1,000 to $1,200. But with volume, we are very sure we'll go down to 400 or maybe even little lower than that. So that is an area which needs significant amount of research, and we are as a company we are doing it, and we are confident of the cost going down. The second area comes is in terms of the electrolyzers or the generation of hydrogen. Now, currently, the generation of hydrogen from uh, SMR using LNG as a raw material, those are not relatively that costly, but obviously they have pollution-related problems. What should be the right strategy for India is to start using hydrogen initially. Maybe it can be, through the SMR route, and at least start using vehicles so that you can see the decarbonization effort. Uh, Going ahead, and that is an area where actually you can make a beginning. The second point is the electrolyzers. The cost of electrolyzers currently is significantly higher. If you look at what Europe is trying to implement, Europe is trying to implement a capacity of around 40 gigawatt in terms of electrolyzers. So that is where even some of the Indian companies have been trying to source some electrolyzers from Europe. They are finding it difficult, and there are no more machines, electrolyzer machines available for the next 2.5 years because everybody is booked. So the cost of electrolyzer has to come down. There should be challenges in terms of how can you bring down the electrolyzer cost, and I think this is where Indian startups can actually play a big role. And I think that is where government is also, going to support. We have suggested to the government to come out with a, innovation scheme for electrolyzers. So I believe that should actually happen in the coming days. The third thing is biomass related technologies which can convert hydrogen, any kind of biomass, whether it is cellulosic or non-cellulosic woody biomass. We can convert that into hydrogen. So I think with the reasonable, see the current prices for biomass in the country, which is currently sold by farmers or taken as a burning material. I don't think is in the range of 800 to more than 800 to 1,000 rupees per ton. So if you are able to give those kind of prices, I think farmers will also benefit. At the same time, the manufacturers will actually get the raw material at a reasonable price so that they can produce hydrogen at a reasonable price. So the parallel area which needs to be worked upon is the dispensing part, hydrogen dispensing part, where the currently the technology is not available in the country, but obviously bigger companies are already started working on that. And there are a few projects which have already been installed in the country. IOCL has come out with the first dispensing station in Baroda, and that station I believe will start working from August onwards. So these are areas which needs to be worked upon, and I think that is where the real challenges will come. And government is supporting. Government is giving a big support to this particular new area. In terms of battery electric vehicles, obviously lithium prices and availability is a challenge. Cobalt pricing and availability is a challenge because 70% of the world's cobalt is available in a country called Congo, and where a lot of children actually work in the fields to dig out cobalt. So that is something which is very dangerous. It is carcinogenic, and these are all challenges are emerging. So stable chemistry like sodium ion or maybe any other new chemistry or aluminum related batteries is something that can probably come up, and I think that will have a great benefit in the coming days. But sodium definitely, because we are working on it, we have seen the results also ourselves. So large scale sodium production, I believe, should start happening very soon, because and that's where a company like Reliance has actually invested in Faradion, a UK based company, and I believe they'll bring that technology to India to make sodium ion batteries, because they are one of the beneficiaries of the PLI scheme, and that is where large scale production of batteries should happen in the country.
Yes, no, makes sense. That
Yeah,
there are definitely challenges on how you switch, especially for heavy duty, long distance vehicles.
yeah, yeah,
Lithium ion just doesn't make a
yeah.
good business case, neither from a not from business perspective as well as a functionality perspective. Now, coming to back to fuel cells, real quick. We do know that you still require a onboard energy storage device, right? Which again, I'm guessing would probably start with lithium ion, and you see that also transitioning into whatever we switch to, probably sodium ion at some point.
Yeah.
Okay.
Yeah,
Uh,
that will definitely happen. See, the problem today is that uh, uh, because of the charging technology also evolving. Earlier we had slow chargers, now people are coming out with fast chargers. But every technology has its advantages, disadvantages. So, people were earlier charging batteries overnight for 7, 8 hours. So the charging time needs to come down. And if you look at a typical, 9-meter bus, which has a weight of gross vehicular weight of around 12 tons, so 11.5 to 12 tons, you have a battery which is almost you'll require a battery which is around 275 to 300 kilowatt hour battery. So the weight of the battery is a significant portion, and I believe the weight of the battery will be in the range of 2.5 to 3 tons. So a bus is weighing 11 tons, is carrying a battery of such high tonnage, and the energy required for carrying the battery itself is very high. So if you look at, as compared to that, a fuel cell will be which can probably run for 300 400 kilometers on a daily basis, will not require that much of space. So space is a constraint, then tonnage is a constraint. A fuel cell with 40 50 kilowatt fuel cell may not weigh more than 400 kgs. So these are all issues and challenges. So technologies will evolve, and I think ultimately, the engineering skills will definitely prevail over the needs of the people, and I think those areas should get addressed very soon. See,
Absolutely.
one very important point I would like to make here. What has actually gone wrong in the last, say, 60 70 years needs to be corrected in the next 15 years.
From a climate
Most of,
standpoint.
so that way you need to put in more money, and that's why McKinsey has come out with the report saying that you need so much of money every year. And I think that's going to be the real challenge for the humanity.
Right. So,
Uh,
if I
can
may,
I?
there's, if we talk about the overall ecosystem, let it be, let's hypothetically say that we have, are switching to fuel cell, and the production and supply of it has been sorted out. From that perspective, there's always this question, whether we should be more focused on the services or design side of things, or the manufacturing side of things. For example, the entire chips shortage, where there are opposing views, right? There's some views which say that yes, it's a good thing that the government is pushing for local manufacturing. There are other views that say that no, the talent should be more focused on designing them and let somebody else, let some other country build them. So similarly, from a overall FCV perspective, right? You have the fuel cell components, you have the energy storage system, you have the existing powertrain, like motor controller. So from an ecosystem perspective, how do you see it, ideally play out from in India, or should be in your opinion, where should we focus on building the tech, but not necessarily having to go mass scale manufacturing versus the other way out. So what are your thoughts on that? I know it's a bit of a broad
Hmm.
question, but I hope you get where I'm coming from.
Yeah. You see, the real challenge for the country, is in terms of the requirement of energy and the transition, because we are so much dependent on imported fuel. Even though we have coal, but in terms of crude, we have too much dependent on outside world. Now, if you look at if you look at our effort in terms of indigenization, most of the fuel cell components we have indigenized. Our import content actually has gone as low as less than 20%. So, it is possible. It is not so difficult to do it. Sometimes you need to take support from countries like China. We initially had imported few components from there, but obviously, using the local Pune ecosystem, the pressing and the stamping facilities which are available in abundance in Pune, we've been able to develop a entire supply chain. And I think that is something which is possible. So suppliers side, see, India auto component industry is 42 billion dollars. I think if we are able to capture onto this particular opportunity, the industry size can be significantly larger. So supply chain is one area where things can actually become better for India, and I think that is where India should look at this particular opportunity, not only from domestic point of view but also from export point of view. Now coming back to fuel, we are seeing all what is happening in Ukraine, and the energy tussle that is actually going on. So countries like Europe has large dependence on say Russia or related countries or neighboring countries from their energy point of view, and they are now wanting to shift 100% to hydrogen in the coming days. So production of hydrogen, low cost hydrogen, and then transportation of hydrogen to these countries, I believe should be another biggest opportunity, because global requirement of energy, whether it is mobility related or manufacturing related, is significantly higher than what we have today. Our requirements are today. So not only meeting the domestic need, but at the same time export, I believe. And that is where the government has come out with this 3-page policy on hydrogen last 15 days before, to really give push, because if we are able to have solar cost at around 2 rupees, and we are able to push the uh, um, kilowatt hour, the units requirement for generation of 1 kg of hydrogen from say current 55-57 units to around 45 units, then I think we can definitely have dispensed hydrogen at 200 rupees per kg in India, and at a mileage of around 14 to 15, it makes a lot of sense to really have a clean transportation fuel being available at say 13-14 rupees per kilometer. So that is where the transition can actually benefit the country. So I hope broadly I'm able to answer your question.
Yes, absolutely. Okay. Um, Final question from my end before we switch to the audience. And this is more to do with the current strategy taken by OEMs. Or strategies rather, taken by OEMs in India. There are still, the whole Maruti, Suzuki, Toyota partnership still focusing on strong hybrids. We all know right now that, yes, for a customer, BEV makes a lot of sense. Also brings that green tag with it. But from a production of electricity, again, production supply from a overall ecosystem perspective, as well as the cost. Right, we just talked about raw materials that go into LII and tech, uh,
Mhm.
sourcing of that, etc. So those things, if you look at the entire picture, those things are problems. Now there are these OEMs that are focusing on strong hybrids. They're about to launch strong hybrids in the industry. There are other OEMs that have gone full fledged into BEVs. Have bespoke platforms going for them. And then we have companies that are completely wanting to focus on fuel cell. So I'd say in the next 7 to 10 years time frame, right? That's I think that's probably the point where we will finally see this play out.
Yeah.
What do you think is, or what in your opinion is the right strategy right now? Because there are companies that are not picking up this, or getting on this electric bandwagon immediately. They are waiting it out. They are giving it a few more years. And also one additional point, sort of a counter opinion, but counter view. But you said that CNG sales haven't picked up, and yes, they sort of got their, or they picked up and they sort of plateaued out. Although we
Mhm.
are seeing recently in recent months that there is talk of having increased number of CNG stations, because in this transition towards full electric, and with the ongoing crises, and as well as the cost of importing fuel, CNG does seem to be something that again OEMs are going with. They are increasing the number of offerings that traditionally were only ICE. They are pretty much all of them are now one by one also having a CNG offering. So from this overall perspective, like what are your thoughts here?
Uh, See, if you look at electric mobility, especially the battery electric part, the real challenge today is the higher cost of the battery, right? Now, in terms of the charging infrastructure, if you look at some companies like Tata Power, they tied up with so many corporations, governments, and cooperative societies that are going to put up charging infrastructure. Now, the pricing for public charging infra in different states is different. It's basically linked to the average power purchase cost or the imported power purchase cost in respective states, and the formula is the APPC price plus 15%. But a lot of states have actually gone ahead and uh, you know uh, come out with a very competitive pricing as far as public charging is concerned. Maharashtra, I think the pricing is around 4.5 rupees. Yesterday, I was part of the Chandigarh EV policy discussion. So the principal secretary there announced the pricing of 3 rupees 60 paisa. So even if your kilowatt hour per kilometer is say 1.1 or 1.2, and 3.6 into 1.1 or 1.2, your per kilometer cost is hardly 4.5 rupees. So as compared to your say 100 rupees diesel cost, and your mileage is say bus mileage is roughly in the range of not more than 4 or 5. So you are against 20 rupees of diesel price per kilometer, you have a 4.5 5 rupees as the running cost. So, that is a very strong attractiveness. And with this recent policy change by the government, if solar pricing interstate, currently if your generation is 2 rupees, your landed price could not, which today is probably in the range of 4 or 4.5 rupees. If that price actually can come down to 2.5 rupees, and companies still make 25% return on the investment, I think that will be a big boost from an electric mobility perspective. Only thing is we need to have reasonably competitive battery solution available, which is from a what we call it as EAM, Earth Abundant Material. So if that is available, I think electric mobility can pick up, and I think most of the bigger companies I think are definitely working on that strategy. But obviously they may not have declared those strategies, but they are definitely looking at those kind of solutions. So second area is about this LNG buses also. LNG buses in intercity, intracity, those buses sometimes they the pricing seems to be around 60-62 rupees per or 70 rupees per liter, as compared to current diesel price of 70 or 100. But I believe the LNG kits are also available in the country at a reasonable price. So retrofitment of existing vehicles with LNG or CNG could be a solution, but you need to really look at how long in the longer term. See, because ultimate aim of all this entire exercise is zero pollution. if you are not moving towards zero pollution from transportation or from manufacturing, then the entire purpose of investing so much of money may get defeated. So, LNG is a good source of energy. The quantity is increasing. I was part of the deliberations and discussions of Indian Gas Exchange also. Actually, I did the valuation for the company also. So I am aware of the kind of business model that they are following. So the current gas requirement may go up from current levels to around 3 or 4 times. But important parameter is that how long you'll keep using LNG? Can it be replaced with something else? So, these are all challenges. So, CNG or LNG, the demand is definitely picking up, but obviously it is for respective companies to look at what kind of models they want to really follow. My only worry is what happened to pagers should not happen to any of these technologies. And pagers actually in 3 4 years of time they started taking off, and the entire technology got wiped out. So it should not something that should happen to any of these technologies. So it should remain. It should be a competitive technology. It should obviously India needs to have 3 4 5 more competitive technologies, but the volume should be significant, and the availability of sustained raw material or sustained source of energy is something which is very critical and important.
Right. So I can, see where you're coming from. The CNG bit, the transition bit for, bit to get to a full scale electric, where the generation is also towards the carbon neutral front,
Yeah.
uh, brings up an interesting point as to how you go about it, or get towards get up to
No,
that point.
you look at recently, I think Reliance chairman also announced, that they want to be the largest producer of blue hydrogen in the world.
Yes, yes,
So, obviously, we all know how Reliance, works, and they work very competitively. They look at the best solutions in the world. We know what strategy they came out to on Geo, and how they are captured actually 40 crore customers in the last 5 years. So we
right,
know all that. So, looking at all that, if he's saying something, obviously, there is much more beyond what he's saying. So obviously, hydrogen mobility. See, understand one thing: a company like Reliance has said 2035 as a net zero, a year for
right,
them. So, look at such a large operation of 8, 10 lakh, 12 lakh crore, group wanting to get into 100% carbon neutrality in every sphere of the activity, including retail, mobile, refinery, everything. So how are they going to achieve that? So if he's saying it, obviously there is definitely a detailed plan and much more larger investment plan behind that. So then you have Reliance, you have Adani's, you have Tata Group. So all these bigger boys and even oil companies, ICL, BPCL, and HPCL have been given targets by government to really work out a strategy on electric mobility, including green hydrogen. So all these guys, and as you would be aware, refineries and fertilizers have been asked to consume 10% of their hydrogen requirement as green hydrogen in the next 2 years, and another 15% in the next 5 years. So
no,
I believe India could suddenly become a large hydrogen market.
I agree with you. Companies that are traditionally in the oil space, in the rather in the energy space in general, this
Mhm.
is a big bet, and they have made big bets. They have also been very aggressive at, integrating smaller firms or
One should
startups into the fold.
understand, Harsh, the challenges countries like Germany is facing today. 70% of the energy requirements are supplied by Russia.
No, I
We
agree.
can.
I agree. See,
Uh,
from having producing green hydrogen and using it as a source to help get towards carbon neutrality. There is
mm,
definitely no argument against it. But if we talk about mobility, right, there is still a bit of an argument from the fact that in India, like especially if you look at the Indian scheme of things, we were at BS4 for a long time. We switched to BS6. People never got a chance to really switch much to it. Even the OEMs had to really cobble something up very quickly. By the time
mm.
it came out, we had to switch to e-mobility, and again the prices are very high. So BS4 to BS6 transition was expensive. Customers, people who are buying and using these vehicles, right? For them, it was a
Yeah, yeah.
big jump.
See, I
Now
completely agree
from
with you.
BS6 to EV,
People are
when the
not even
EV,
required investment in BS6.
just allow me a moment, please.
Yeah.
If when that switch happened from BS6 to e-mobility, again the price today,
Mm.
everybody talks about range anxiety and everything is secondary. We don't have a Maruti 800 version of EV in India yet, and whatever is out there is at a price point that most customers are not going to even like a fraction of the market goes for it, right? Now, if
Yeah.
we talk about fuel cell again, it's going to be the same thing. Maybe the generation and supply part of it gets fixed, but
Mm.
we all know that the fuel cell components aren't really cheap to come by. So
Mm.
there is also this component of how do you see the end user going for it? Does it make sense to wait it out and have some sort of a transition again in between? Because a larger part of the market doesn't end up using the newer technologies that we talk about for a longer time, mainly because, again, due to the cost aspect of it.
Yeah.
The generation
But
of green hydrogen is
yeah.
fantastic, but then the components for a fuel cell vehicle that also still are quite costly. So I think that do you not think that this is sort of a uh, difficult thing for consumers to digest, where every few years there is something new, which is again expensive?
Yeah, I mean, I have seen the pricing for most of these current, SUVs, electric SUVs, and the comparable prices. So obviously, there is large difference today. Uh, See, the transition is going to be challenging. It's going to be painful. We need a much more sustainable policy framework, and the policy framework should remain there for minimum 10 years. See, India has seen large policy changes, and at this point of time, we need much more sustainable. If the government is going to support FAME 2 policies, through FAME 2 for all the electric vehicles, and I believe a lot of states have also come out with policies on, fuel cell on this battery electric support there. So I think we believe Maharashtra is giving some 1.5 lakh rupees incentive over and above what FAME 2 is actually giving. So these are see the challenges will remain. We need a much more policy. Only solution to this is a much more longer term sort of a policy framework with clarity on what is going to happen in the next 10 years. Then I think people will take a bet, because if I had to, instead of a 10-12 lakh vehicle, if I had to invest in a 15 lakh vehicle, my only question would be how viable it will be in terms of the energy cost and the fuel cost, and how, whether I can recover that money. Range anxiety related challenges are obviously there. We've seen that some of the manufacturers committed 300-kilometer range, and in reality they are not getting more than 225. So these challenges will remain. But let people get accustomed to it. Let the policy parameter remain for a more number of years so that they can really plan for it. And see, this transition is going to pain everybody. So one should be prepared mentally, whether it's a MSME or a large company or an individual. So that cost will
Yeah,
come
no,
to.
I like your point. I like your point about policy because I think what's important is to
Hmm.
have a roadmap where we stick to a certain idea, because so far it seems that we tend to
Hmm.
play
Yeah,
catch up, and we tend to switch very quickly every time we
yeah,
see something going on in the industry in general. So
yeah.
no, but I get you. It has to be policy level, and if there is a longer roadmap, then absorbing the prices,
Hmm.
sort of gets amortized over time, sort of like
Yeah,
something like that. Okay. No, great.
Hi.
I
Hello.
thank you for that. I
Yeah,
can
Harsh.
we
Yeah. Can we
Yes.
ask? Is it open for audience as well?
Yeah, I was just about to announce that.
Vijay.
So please go ahead.
Yeah. Yes, I think excellent presentation, Mr. Chandrasekhar. I think, and I also appreciate Shekhar for bringing different topics, of our interest. Uh, I really appreciate Shekhar Malani's, passion for EV and bringing new subjects and people like you on board. So thank you for all that. Uh, I have one question. I attended this Faradion
hmm,
conference in Delhi,
okay.
and when they
Yes,
came
Saeed.
first time in India,
Hmm.
I realized, what they said. The basic problem that they're facing is about that current sodium chemistry is more suitable for the stationary application. So, what are the challenges being faced currently on the sodium ion, development?
See, sodium, as you would be aware, the energy density is low, power density is high. So, but the only advantage is that if you have a 200 kilowatt hour battery in a bus, sodium, because of high power density, maybe you can have smaller size batteries which can be where the C rate can be actually 3 or 4 or 5, and you can probably charge the batteries in 10-15 minutes. So the solution that we are working upon, we see, say, a typical bus which is running say 200 kilometers daily. then first stretch of say 60 kilometers, then it can be charged after 60 kilometers for 10-15 minutes. And we don't go down at any point of time. The depth of discharge will not be more than 80% at any point of time, so that we have buffer available. And these are challenges which are getting addressed through sodium ion. Obviously, the chemistry improvement and whatever cell level improvement, is going to obviously take time. But see, we have invested in that particular technology. Even bigger companies like Reliance have now taken over for Radiant. So I believe improvements will happen. But obviously, you need battery solution from the point of view of a ranged mobility, which is not more than 200 or 250 kilometers on a daily basis. So I think that for that solution, sodium ion chemistry is definitely good. And other than the stationary, we have done some work on the stationary applications. We're talking to a lot of people on this IT parks use, and including the telecom tower use, etc., etc. So we see great application in those stationary applications. Even on the mobility application side, three-wheeler, four-wheeler, or even buses is definitely going to be a great opportunity. Only thing is the experimentation part, or the near-term gestation in terms of deploying the technology and testing it. It will probably take another 1.5-2 years, and I think after that things will probably the applications will actually be much more wider than what we can think of.
Thanks. But I think the energy density may be comparatively quite low
It
compared
is
to sodium ion.
low. It is low. I think it is, as compared to lithium ion. It is, I think, 40% of lithium ion. So
Yeah. So that means you are again going to have a bigger, weight for the
that's
battery.
why, if you improve the C rate and you come down to say around 6 or 7 C, then you can charge the battery in 7 minutes or 8 minutes.
Okay. And just one more last question.
Yeah.
Tell me, do you think any difference in the powertrain configuration when you have a fuel cell or a battery electric? Any
No,
changes?
the fuel cell, see, because we have tested our fuel cell for 3 buses already, and it has run for 6 lakh kilometers. The same fuel cell can be used for, the powertrain actually can be even used for a fuel cell vehicle. So there is no issue at all.
Okay. So there is no, based
Yeah,
on your
there is
experimentation,
no issue
it's
at all.
perfectly all right.
Yeah, it's perfectly all running perfectly well with the best efficiency in the country today. We have an ARI certificate which says the efficiency is so much, and it is 20% better than the competition. So, and that same powertrain can be used for fuel cell vehicle. Fortunately, because of our global experience and understanding in the EV, the mobility market, we've been able to have a supply chain for even powertrain, done up very well. So entire motor controller, ECU, BMS and ECU is our own technology product. So we developed them ourselves, and motor controller is where we are currently doing the entire work, and we are trying to move from a 4 motor solution to a single motor solution, and that also induction motor, not a permanent magnet motor. Because permanent magnet, again, there are issues and challenges. And we recently heard in one of the conferences that BMW is moving from permanent magnets to induction motor.
Yeah,
You know,
yeah,
so,
yeah. Yeah.
so these are all very important things that are happening globally. So our thought process in terms of moving to induction motor on a R&D side was definitely way ahead of the others, and I think the single motor solution will definitely benefit the industry in the coming days.
And when you say induction motor, up to what kilowatt you are talking about?
Uh, See, in terms of the what you call it as Newton meters, it is
Yeah.
around 2000, 2200 Newton meters. So we are
Kilowatt.
trying to
In terms
improve
of
that to around
kilowatts.
2700.
In terms of kilowatts.
In terms of kilowatt, I'll have to work that
150
out. But
kilowatt, 150 kilowatt, or 200 or 20 or 15 kilowatt. It is for the
I'll have to
application
work
of
that. I'll have
buses.
to
Is
work
it?
that out. But as I told you, the number in terms of Newton meter, that is the number we currently have, and we're trying to improve from 2000 to 2700, 800, so that we are able to meet requirements for much more, sort of much more bigger gradient issues, which actually come when you actually drive a bus, because our initial focus is on buses.
Okay. So mostly for
Yeah,
buses. Understand. Yeah. Okay.
yeah.
Okay. Yeah. Thanks. Thank you. Thank you very much.
So, any other questions?
Mr. Deepak? Yes. So we have two more questions.
Yeah.
So, Mr. Deepak, if you would like to go ahead and ask your question.
Yeah. So, sir, I want to ask, like, we are, as you rightly said, I think Harsh also said that now the customers, like a person like me, who is having
Mhm.
a diesel vehicle as well as one gasoline vehicle, now wants to move to the electric vehicles. But
Yeah.
going by the cost deterrent, it is a big challenge. And I don't
Mhm.
know how long this life cycle of the electric vehicle will last. Maybe if hydrogen vehicle, if it is coming, you know, early.
Mhm.
So
Mhm.
basically, like to know whether I should continue for the CNG variant or I should go for the electric vehicle, or and when is the hydrogen cell technology will be coming on the personal vehicle.
See, hydrogen fuel cell technology in personal vehicle is already there. If you look at Toyota, see the different
I'm
corporates.
talking in India. Yeah.
Yeah, yeah. So let me explain. So in terms of fuel cell, the technology is already there on Toyota Mirai. Toyota Mirai has had many runs in India, including our honorable Nitinji Gadkari, Transport Minister, having had a ride of Toyota Mirai. So that particular vehicle, in I think 5 or 6 kgs of hydrogen, it has ran for almost 1,000 kilometers. So very efficient vehicle, and you can imagine the kind of mileage it is giving if you are consuming hydrogen uh, uh, for around 1,500 rupees of hydrogen or 2,000 rupees of hydrogen, and you are running for 1,000 kilometers. You can imagine what is the kind of efficiency you have for the fuel. So obviously, hydro they have their own strategy of probably Toyota never did any work on battery electric vehicles. They straight moved to fuel cell electric vehicles. So that was their philosophy. Now they are thinking twice about it, but obviously their focus remains on that. So the transition will be painful. It is very difficult for anybody to really take a guess as to how there's any individual who actually wants to move from current ICE to battery. What he should do, because lower end pricing is not available. So these are challenges which will remain. See, a lot of people in metros have already started shifting to battery electric because they want to have that experience and don't want to actually go to the petrol pumps and diesel pumps. They want to avoid going there. So it's a question of mindset. It's a question of personal cash flow. It's a question of how you look at your own contribution. See, as I said, it's challenging. It is going to be transitionary. It is going to be cost, and not only the corporate cost and the government cost. It is also going to have pain on our personal pockets. So one should look at it that from that point of view and take a decision, because it's very difficult to comment on. Government is very keen. Government is pushing oil companies to do everything that they can make hydrogen available, and there are certain electrolyzer companies who have targeted $1 per kg of hydrogen by 2025. If those things happen, probably you'll probably have much more. But personal vehicle in terms of hydrogen will take time. But I think the public transport vehicles like buses and trucks, because heavy duty transportation 400 kilometers per day is something that is best suited for hydrogen mobility.
Okay. Thank you, sir.
Yeah.
Okay. So we'll call it a day for today. I think
Yeah.
we've overshot the time, but thank you so much for taking out this time and making this happen. Any parting words from your end? And this.
As I said, energy transition is going to be very painful. Everybody needs to contribute to that. It's the responsibility of every one of us, because and otherwise the Mother Earth won't survive. So it is very, very important for all of us to do whatever best we can do to look at decarbonizing the world in whatever way we can. I think that's the best message I can give.
Definitely. Thank you so
Yeah.
much, sir. Have
Thank you.
a great day.
Thank you. Have a good day. Thank you.